boys and girls. We're going to be doing a few things in math today. The first thing I wanted to do was review how to subtract across the zero in 4-digit subtraction. There was a little bit of confusion on the learning board last week. It said to do this page subtracting across zero, but I forgot to talk about it in the video. So some of you did this page and some of you did not, and that's okay because I'm going to go over a few on the board here. And then if you have not done the page yet, you can go ahead and work on that today. So subtracting across zero in a 4-digit number is just like doing it with a 3-digit number. You're going to start over in the ones and you're going to look, can I do 0 take away 9? No. So you go next door, but there's none there. So you go next door, still none there, all the way over to the thousands place. The 5,000 turns to a 4,000, and then we get a 10 in the hundreds. Now we can go borrow to the tens, and that'll turn into a 10. We still have one more place to go, so we'll turn that into a 9, and finally we'll get a 10 in the ones place. 10 take away 9 is 1, 9 minus 8 is 1, 9 minus 2 is 7, 4 take away 1 is 3, 3,711. There's one more kind of problem I wanted to look at because a lot of kids had some trouble with this. If we have 0 minus 0, you do not need to borrow. You can just say 0 minus 0 is 0. A lot of kids were starting their borrowing there and getting the wrong answer. So 0 take away 0 is 0. 0 take away 9, now we can't do that. So we're going to go next door. They don't have any. Go next door again. 3,000 turns to 2,000. 10 in the hundreds. Now I'll borrow that and go over to the 10 spot. So 10 take away 9 is 1. 9 minus 7 is 2. 2 minus 1 is 1. My answer is 1,210. So again, if you already did this page, great. If you have not done this page, this is something that you should do. Moving on to today's work, we are going to be talking a little bit about equations, equals, not equals, fact families, some things like that. So I need you to get your math packets out because we're going to be going through this together, and some of it I'll be having you fill in some answers together. Get your math packet out and open to page 119. Once you are there, the first page talks about two symbols, the equal sign and the not equal sign. Now, the equal sign means that on both sides of it, they equal the same thing. So I think of it like a scale that's perfectly balanced. So, for example, I might say 5 equals 3 plus 2. Both sides of the scale weigh the same thing. They're the same number. Now, this symbol here, this not equals to, means that they are not balanced. The scale is tilting one way or the other. I might say something like 10 is not equal to 2 plus 2, because 2 plus 2 is 4, and that is not equal to 10. Now, for numbers 1 and 2, it wants you to write a few examples. So number 1 says, use the equal sign to write 4 equations, just like I did here. Here's one that I did, 5 equals 3 plus 2. You're going to write 4 different equations that are equal. Then for number 2, you're going to write 4 equations that are not equal, like my example, 10 is not equal to 2 plus 2. So I'd like you to pause your video, and I'd like you to fill in 4 equations for each, for number 1 and number 2. When you're done, you can unpause the video and we'll keep going. All done? Okay. Now for numbers 3, 4, and 5, we're going to look at these and decide, are they equal or not equal? Are the scales balanced or not balanced? Let's look at number 3. Number 3 has 5 plus 2 plus 6 on one side and 6 plus 7 on the other side. Well, I know that 7 plus 6 is 13. 7 plus 6 is 13. Those two sides are equal, so you'll write equal into the circle by number 3. Number 4, 80 on one side and 60 minus 20 on the other side. Well, I know 60 minus 20 is 40, so these are not equal. How about number 5? 70 on one side and 30 plus 40 on the other. What do you think? If you said equal to, you are correct. What I'd like you to do next is to flip over to the next page, page 120. It says, discuss the commutative property. So go ahead and get that flipped over. And on this page, you don't need to fill anything out. I just want to talk to you about what the commutative property of addition is. What that means, it's a fancy way of saying that it doesn't matter what order you add numbers up in. So it means you could say 4 plus 3, or you could say 3 plus 4. It doesn't matter. They both equal 7. So you could add numbers up in any order. If you have 7 plus 1 plus 2, and then you have 2 plus 7 plus 1, you can add these up in any order. If I said, okay, 7 plus 1 is 8, 8 plus 2 is 10, I could also say, oh, okay, 2 plus 7 is 9, plus 1 is 10. It basically is saying, in addition, you can add the numbers up in any order. Now, this is not true for subtraction. It does matter what order the numbers are in when you subtract. For example, 13 minus 7 is not the same as 7 minus 13. So subtraction, the order matters. Addition, it does not. Flip over to page 121. On this page, we're going to talk just briefly about fact families and how addition and subtraction are related to each other. They're called inverse operations, which mean they undo each other. They're opposites. So if you had a fact family and you had 3 and 4, 3 plus 4 equals 7. Well, what we talked about before with the commutative property, that also could be 4 plus 3 equals 7. Now, how these numbers are related to each other is that we can use subtraction to undo it. 7 minus 3 equals 4, or 7 minus 4 equals 3. The three numbers can all be used in the addition and the subtraction problems. Now, what I'd like you to do is just to take a look at numbers 11, 12, and 13. In 11, 12, and 13, there is something new that we haven't talked about. There are problems that have variables in them. And let me talk to you a little bit about what a variable is. A variable is when we use a letter to stand in place of a number. For example, in number 11, it says 50 equals 30 plus p. And we need to try to figure out, what does p equal? Well, 30 plus what would equal 50? 20. So p equals 20. Let's try number 12. 12 says q plus 20 equals 60. Now we need to figure out what q stands for. Something plus 20 equals 60. Well, I know that 60 minus 20 equals 40. And finally, number 13, it says 90 minus v equals 50. So I need to figure out 90 minus what is going to get me to 50. If you said 40, you are correct. So some of your work today is going to involve using variables to figure out the solution. I'm going to do one more page together. Well, I'm going to go over the directions of it together. So this page says inequalities. It says a number sentence that shows that two amounts are not equal is an inequality. The greater than sign shows that the quantity on the left is greater than the quantity on the right. For example, 9 is greater than 3, 6 is greater than 0. The less than sign shows that the quantity on the left is greater. 5 is less than 7. 0 is less than 1. So you are going to read the directions for 1 through 12 to make these statements true. You're going to, for 1 through 6, you're going to write in the greater than or less than symbol. For numbers 7 through 12, you're going to write a plus or minus sign to make each statement true. Then your assignment for today is to do homework 3-1. So you're going to go through and do this page. On the back where it says remembering, you are going to exit. We are not going to do that page. So you're just going to finish up on the inequalities page and then do the homework 3-1. Let me know if you have any questions.